My name is Kelly Greenlee. I am the Community Outreach Librarian at Prince Memorial Library. Very happy to have you here this evening. And it's my pleasure to introduce to you Penny Asherman, who is the Executive Director for Chesapeake and Cumberland Land Trust. Penny became the Executive Director of CCLT in 2022 after serving as a board member for 18 years. She was a member of the Cumberland Town Lands and Conservation Commission and continues to serve as a liaison between CCLT and the town of Cumberland. Penny also serves on the board of the Maine Conservation Voters and Alliance, working on statewide environmental policy issues. She has a BA from Bowdoin College and a law degree and master's degree from Vermont Law School. Penny?
Thank you so much, Kelly, and thank you all for joining us this evening. Really excited to have you here and learning about climate action. CCLT, as you probably know, has been conserving land and protecting water quality and providing public access to nature for 37 years in the town of Cumberland and town of Chesapeake Island. We have 1,200 acres of conserved forests, fields, and shoreline, and we hope that you're all enjoying them. Tonight, we're excited to have our third event in our climate series that we coordinated with our partners, Prince Memorial Library, Town of Cumberland Lands and Conservation Commission's Sustainability Subcommittee, and the Chesapeake Island Climate Action Team. The series that I'm referring to is called Weathering Climate Change, Understanding Shifts in Our Local Landscape. It's a series of 9 walks and talks aimed at informing, engaging, and uniting community members around local climate issues that are impacting us all. Some of our talks are online, like tonight. Others will be taking place out on the land, and we hope that you'll be joining us. Throughout the series, we're learning about our changing weather and coastlines, how our forests, birds, and marine populations are adapting, the role of our local farms in sustainable agriculture, and how you can make a difference individually. I will do a pitch for our next event, which is May 23rd, and that is all about local climate action. So we'll be hearing from the town of Cumberland, the town of Chesapeake, MS80 51, and CCLT, learning about what we're all doing for climate action and how we can do things collectively together to make a difference.
Penny, can I interrupt for just a minute? I'm sorry. Yeah. We also have a virtual program coming up on May 14th, which is a Tuesday. And that one is about stabilizing our coastlines.
Right.
So I don't mean to refute you, but I just wanted to make sure
that's perfect. I'm glad that you mentioned that. And tonight we're really excited to welcome Curtis Bohlen from Casco Bay Estuary Partnership to talk about a place we all love and enjoy, which is Casco Bay. And we're going to be learning from him some of the latest about the State of the Bay report that they put together, the importance of land conservation for water quality, measurements of bay health, and how Casco Bay Estuary Partnership is working with towns on ways to make the bay and communities more resilient. And I also want to take an opportunity to thank Casco Bay Estuary Partnership because they have supported many of CCLT's land acquisitions with grant funding. They've also partnered with CCLT in the town of Cumberland on community education projects, and we really appreciate their support and leadership in land acquisition. So I'm pleased to introduce Curtis. He's the director of Casco Bay Estuary Partnership. And he's an aquatic and wetlands biologist with an interdisciplinary background in ecology, economics, and public policy. He works to seek creative solutions to environmental challenges, support local communities, and improve management of Casco Bay. And in recent years, the organization has expanded its efforts to assist communities to understand and prepare for the impacts of climate change. Curtis has worked as a legislative aide on Capitol Hill for an environmental advocacy organizations, as an environmental consultant, and on the faculty of Bates and Colby colleges. He holds an undergraduate and master's degree from Stanford and a PhD from Cornell. So thank you so much for joining us, Curtis.
It's a real treat to be here, and thank you, Penny and Kelly, for the introductions, and thank you for inviting me. I told you all as we were getting set up, and I wanted to share with the audience that this talk is, I give talks like this fairly regularly, and I thought this would be an easy one to pull together, and I just use a collection of ideas from before, but I found as I sat down to pull this together that this was a hard one for me to pull together, because the way we think and talk about climate change and how it relates to our work as the Estuary Partnership has been evolving. And I really needed to think about how to capture some of that subtlety of the new ways we're seeing how we work. And so this is a little bit of a new version of talking about these ideas. We'll see how it goes. But it should be fun for me to get in and get into some of the details. So let's get it started and we'll get going. Let me get the screen share going. Okay, that looks like that popped up a screen share. Thank you. I'm going to talk a little bit about state of Casco Bay, but most of what I want to focus on today is really thinking about how climate change is affecting Casco Bay and the communities around Casco Bay, and how that is changing the way we as the Estuary Partnership think about our work and think about the kinds of work we need to do. And I want to start with a little bit of a teaser, and that's just a couple of photographs. This is two photographs taken from almost exactly the same point at the boat launch at the head of McCoy Bay by Hillary Nichols, who's a biologist who's recently retired from the U.S. Geological Survey. And these are two photographs essentially of the same view that were taken 12 years apart. And the first one on the left shows abundant intertidal eelgrass, and the right side shows bare mud. This is, in fact, a consequence of climate change in Casco Bay, but in a very roundabout and difficult way to explain. So because climate change does not operate alone. It operates in the context of many other kinds of things that are happening in the bay at any given time. In this case, the dominant thinking about what's driving it is the little creature on the left-hand side of the screen, which is the Eurasian green crab. The green crab first was spotted in Casco Bay back in 1905. And it's been around for a long time, but its populations fluctuate dramatically. And in 2012 and 2013, we had a pair of very, very warm winters. And the green crab populations boomed, and the green crab shredded eelgrass. And we saw a huge decline in eelgrass following those 2 years. And one of the consequences was seeing that bare mud. Green crab, of course, has not disappeared, and we've had more warm winters since, so it's been interesting here to go. I want to show the changes in eelgrass over the last couple of decades. This is a map on the right-hand side showing eelgrass in Casco Bay back in 1993. And you can see it's pretty extensive. There's about 7,000 acres of eelgrass around the bay. Most of it fairly dense, but not all of it. A lot of it in the upper northern portions of Casco Bay. By 2001, we actually had about 1,000 acres more eelgrass and around the bay. Again, a lot of it in that upper portion of the northern bay and the eastern bay, where we had these gigantic eelgrass beds. They're really quite impressive to go see. By 2013, however, the abundance of eelgrass had dropped by more than 50%. And that was the 2013 is right after those 2 warm winters. And you'll notice that we've lost almost all the eelgrass in the upper portions of the bay. By 2018, we were thinking things were looking better. They were coming back. We hadn't had another warm winter. The green crabs have been knocked back by a couple of cold winters, and we started to see some natural recovery. And we were feeling pretty optimistic. Okay, things will be back to normal. And then we had a couple of warm winters, and by 2022, we were down to 2,000 acres of eelgrass again. So this is a climate change signal, but it's a climate change signal mediated through a non-native species that came from Europe. So it's not just climate change, it's climate change interacting with other forces that are affecting Casco Bay. So we can look more broadly and think about what are some of the other changes we've seen in Casco Bay. And many of these, I can come up with a plausible argument for how these changes are related to climate change, but almost all of them have a similar complicated story. We just talked about eelgrass and its declines in eelgrass, how it's climate change, but it's also green crabs, and it's also other kinds of stressors. Same thing with clams. We can talk about changes in clam abundance, and some of that is climate change, and ocean acidification, but some of it is green crab, and some of it is other predators that are more common in Casco Bay now than they were 30 or 40 years ago. Blue mussels, largely gone, probably another signal of green crab impact. Northern shrimp, they moved further north. We were at the southern end of the range of the northern shrimp, and as the oceans have warmed, they've moved further north. Cod, reproductively, first of all, driven offshore by fishing practices, then warmer waters lower their reproductive rates, and cod are declining throughout the Gulf of Maine. And sea stars is a bacterial disease that's been affecting them. So, many different species that are changing in the bay, and many different changes which are related to, but are not directly, I don't want to say they're caused by climate change, but they're influenced and exacerbated by climate change. The flip side of that are the new species that are turning up in Casco Bay, and these are two that have been of particular importance because they're commercially potentially valuable. And those are the black sea bass and the blue crab, both of which have got really, really robust commercial fisheries in the mid-Atlantic, and so have been of great interest to fisheries folks in the state of Maine. The black sea bass, what's interesting about that is the permits that allow you to catch black sea bass are mostly held by people who live in New Jersey and places where the black sea bass used to be abundant, and people in Maine don't have those national level permits. So even though the fish are becoming more abundant, it's hard to get permission to harvest them. Blue crab were, until a few years ago, we saw them regularly in Casco Bay. They would overwinter, and they would not overwinter in the bay, but we'd see them in the summer. And we very seldom saw juveniles or saw larvae. But over the last 5 or 6 years, we started looking a little closer, and the waters have gotten warmer, and we see them more and more common. And so we're looking at a potential change in a dominant fishery for another crustacean. And that could be a huge change in the economics of the coast of Maine. And then there are a variety of things that we call invasives. The green crab is up on the top right-hand side of this picture. The two blobby things are what are called tunicates, and they are an invertebrate. Interestingly enough, they're actually in the same phylum as us as vertebrates. They're more closely related to us than the other things on this slide. And in the lower left is something called a skeleton shrimp. And I've seen places in the Harrisseacut River in Freeport where the entire side of the dock was completely covered with these. There is a native version of this, but the native version is essentially gone when we look and see what we're finding in the area now. So we're getting these new invasives. Some of them we would be getting regardless of climate change. Others can only persist because our winters is not as cold as they used to be. So I want to give very briefly an overview of who we are as the Estuary Program. I don't want to spend a lot of time on this, but to give you a sense of what the Casco Bay Estuary Partnership is and how we operate. We are one of 28 national estuary programs around the country. What the estuary programs have in common is we get core funding from EPA to work as a local coalition for working on behalf of an estuary of national significance, in our case, Casco Bay. And we have a couple of requirements. We have to have a locally led leadership structure, and we have to develop a locally developed plan for what our priorities are. We are hosted now at USM's Muskie School of Public Service as part of the Cutler Institute. We have a 23-member advisory board. And actually, I saw on the list of folks listening in, at least one of my management committee members, who's what we call that group, is listening in today. So I better be careful what I say. And we are charged with implementing the strategic plan. And we have just updated our strategic plan. And one of the reasons why I had to rethink this talk was because we are rethinking how we do everything in light of what we've learned over the last decade or so about climate change and its effects on the bay. We are locally led. We have no regulatory authority. We try to be science-based as much as we can. We want to focus very much on the watershed and think about the whole watershed of the bay. And we want to think about how we can be collaborative and bring people together to do better work. So we're not going to tell anybody what to do, but we're certainly going to try to encourage people. Our Casco Bay plan in its newest version has 4 major sections, and I'm not going to go through this whole slide, but to give you a rough idea, number 1 is habitat, thinking about protection, what Penny mentioned with our habitat protection grants, but also a lot of habitat restoration work that we're engaged with. The second is a focus on water quality and really thinking about the impacts of human activity on water quality and what we can do to reduce that. The third area is engaging communities and figuring out how do we support local decisions and help communities make wise decisions about water resources and about climate change, because those two are linked in Maine. You can't touch one without touching the other. And then fourth, we want to mobilize knowledge and resources as best we can in order to support good decision-making and good conversations about what our future ought to look like. So when I'm talking about Casco Bay, most of you will know this body of water well. Look at this map every day. It extends from Cape Elizabeth to Phippsburg. It's about 160 square miles of water. Interestingly enough, in that 160 square miles, you've got about 575 miles of shoreline. There's about 785 islands that are big enough to be mapped on the old topo maps. And it touches 13 coastal municipalities. We'll talk a little bit later, if I have time, about a new ocean model that we've been working on. And the modelers who are working on modeling water movement in Casco Bay tell us this is the most complicated geometry they've ever worked in. Mm-hmm. This is not a simple body of water. And the water movement in this bay is very complicated because we've got these strong tides that slosh in and out between the islands, and we have relatively small rivers. So the bay as a whole is mostly dominated by the marine environment with relatively little freshwater inflow. But they're right around the corner is the Kennebec River, and the Kennebec River puts so much water into eastern Casco Bay that the salinity in eastern Casco Bay actually is higher closer to shore than it is offshore. We have what's called a reverse estuary, where the higher salinity is way back up in the coves where the water from the Kennebec doesn't get as readily. But when we think about our work, we don't think just about the bay. We think about the whole watershed. We think about moving all the way up to Bethel as the northern tip of the watershed. It's just under 1,000 square miles. 48 municipalities touch Casco Bay. About 40 are mostly in Casco Bay. So it's a large number of towns. When we think about working with Maine's locally controlled land use policies and things like that, we have a lot of communities to talk to. About 60% of that watershed is forested. We've got a big lake in the middle of it, so that also affects water quality dramatically. But this is, in many ways, the center of a lot of the economic activity in Maine. We're looking at about 4.5% of the land area of the state of Maine. It contains about a quarter of the population. About 32 or 33, call it a third, of all jobs in the state of Maine are in this watershed, and about 40% of all economic activity occur here. So this is an important area for the state economically, and an important area socially and politically as well. So this is one of our points where we can stop and say, questions or comments? Anybody want to toss something into the discussion, or we can keep moving into the next section? I'm seeing nothing popping up. Should we just keep going then? We'll keep going.
I would say keep going, Curtis. Thank you.
Yeah, okay. So I want to now talk a little bit about sort of the climate change drivers in Casco Bay. And what I mean by that is the things that we might think of as being the core of climate change: temperature, rainfall, sea level rise. And I put coastal acidification on this slide because it is part of the climate change story, but for time reasons, I'm not really going to talk about it today. So if we look at the data from the Portland Jetport, we can actually look at an 80-year record of weather from the Portland Jetport. And we can go back and look at that, and we can ask about how do we see that climate has been changing. And one of the things I want to get across to you is that climate has been changing. This is not something new. Climate change has been occurring according to the directions that one would expect due to increasing carbon dioxide in the atmosphere in Maine for most of this 80-year period. So this is not a new phenomenon that things are changing, but they have consequences, and they have cumulative consequences. So what I want to start with is saying the weather is getting warmer, but the pattern of getting warmer is not trivial. The summers, we don't see any statistically significant change in how warm the summers are yet. Might be there, but it's not popping out of the statistical noise yet. Winters, on the other hand, are getting a lot warmer. And one of the consequences of that is we're getting fewer and fewer days below freezing and fewer days below zero. So the winters are warmer, we're getting fewer days that are very cold, and we're getting therefore a longer and longer growing season. Our growing season has increased on the order of a month over that 80-year period. So this is a pretty significant change. And if you think about this, not just in terms of growing your garden, but in terms of what this means for organisms in the marine environment, the warmer winters have a big difference in terms of who can survive here. Long, cold winters really limit who can survive in Casco Bay because of the difficulty of surviving that long, cold winter. And we can see these differences in air temperature. If we look at the records in Casco Bay, this is a shorter record. This is from the Friends of Casco Bay's long-term water quality monitoring program. They've been collecting data on a roughly monthly basis during the warmer months of the season for about 30 years. And I've divided the data here into spring, summer, and fall categories. And in all three seasons, the water has been getting warmer. And it's gotten warmer on the order of 1.5 degrees Celsius or almost 3 degrees Fahrenheit over a period of 30 years. Again, that may not sound like much, but marine environments tend to be very stable in terms of temperature, and a 3-degree change in temperature is pretty significant in a marine environment. So we're beginning to see temperature change, and that's having effects on all those organisms that I was talking about a minute ago. The other half of climate change that people are not always aware of is changing storms and storm intensities. And we're getting more rainfall now than we did 80 years ago. We've gotten to the point where over the period of 80 years, the amount of rainfall falling per year has increased on average by about 10 inches a year. So we've gone from just under 40 inches a year to just under 50 inches a year on average. You look at those gray dots behind that, though, and you realize there's a lot of scatter here. This is not a tight relationship, but it's there, it's meaningful, it's statistically significant. So we're getting more rainfall as a total, but the other half of this change is that more of that rainfall is coming in bigger storms and less is coming in small storms. And the way we can document that more easily is by looking at 24-hour periods where you got at least an inch of rain. You can look back 80 years and count how many days a year you got more than an inch of rain. That's the top blue line. Back in the 1940s, we were getting more or less 8 days a year with an inch of rain. And by the 2010s, we were looking at about 13. So from 8 to 13, an increase of about 5 big rain events a year at the 1-inch level. But if you look at the 2-inch rainfall level, they were fairly rare. Many years in the 1930s and 40s and early 50s, you didn't get any rainfall events over 2 inches in size. And now we typically get about 3 a year. And we've had our year's quota this year, I think. But it's that change is very strong and very robust statistically. And sea level has been rising. And this slide I actually had to remake yesterday because the last couple of years, the slide I used to have was made for our State of the Bay report, which came out in 2021, early 21, and didn't include the last couple of years. And I just want to point out, there's this little bump up in sea level over the last couple of years, and nobody's quite sure why it happened. But it is there, and it seems to have been a big jump. We've done some pretty careful statistical analysis, and you can see some earlier periods with similar bump ups. So we don't know whether it's meaningful or not yet. We don't know what caused it yet. And there's a lot of discussion in the scientific community. And we don't know whether it's the beginning of a trend or whether that's just a short-term bump like occurred back in the 1970s. So we'll wait and see. But it's been very important. It's important because of the impact it had on the January storms. The 2 January storms we had this year were especially difficult because of a confluence of 3 events. The first is the storms were coming from a different direction. The wind direction was coming from a different direction. Traditionally, our winter storms are nor'easters. And this time the storms, mostly the winds came from the southeast instead of the northeast. Much of our infrastructure, people are smart. You don't build things on an exposed shoreline. You build them in protected areas. Well, protection from what wind direction? That's something that's based on your experience and history. And so we've got a lot of infrastructure that was built with the assumption that our big winter storms would come from the northeast, and this one didn't. So the other effect of this is it piles up more water on the shoreline. It blows the water up into the bays and coves and causes a larger storm surge. On top of that, we had that anomaly last year of those big high sea level rise. That sea level is 8 inches or so higher last year than we would expect based on long-term trends and based on astronomical forecasts. So we had a bump up for the whole year, and on top of that, we had a big storm with a higher than usual storm surge and a more intense storm than we expect. And then the last piece of why these storms were so damaging is they occurred at high tide. The core of the storm surge tend to happen right around high tide. So we had a sort of a confluence of things that all happened simultaneously. Some of those are climate related, some of them were bad chance, and some of them are likely to be more common in the future. So let's look at what it means, though, to think about flooding. It turns out a gradual sea level rise does not lead to a gradual increase in flooding. As you increase sea level a little bit, the frequency of flooding goes up a lot. And I've got a slide in a minute to try to explain why that is, but this is one of the issues we're dealing with, is that floods are when it gets above a level we're concerned about, and that level is based on how we built up the coast. Again, people are pretty smart. You build the infrastructure near the coast, you build it near sea level, because that's the easiest way to get to the water. But as sea level starts to rise, you built for the past, not for the present and the future. So here's the reason why this tends to happen. We've gone from, over the last 80 years or so, or 100, or more than that in this case, from 110 years, from about one flood every 2 years above what we would now call the highest astronomical tide level, which we're using as a flood level for this analysis, up to having about 8 floods a year now above that level. And there's a reason why that curve isn't straight. And I wanted to tie in what we're talking about here. It's mostly not big storm floods like what I just talked about. We're talking about things where the tide is just a little bit higher and it's a little bit above the infrastructure we built. Like this example from 2011, where the parking lots down on the Portland waterfront went underwater just because the tide was high. Blue sky, no storm, just higher tides. So here's the logic behind it. This is actually looking at data from a period from 1983 to 2001 for technical reasons. But what I've drawn is a big black line across here that shows the flood level. This is what we would call the highest astronomical tide. And you can see that even during that period in 1983 to 2001, there were a few days when you had high water levels. Just by chance, some days are higher than others. If you raise sea level by 3, I'm literally just moving those dots. If each one of those is a high tide. We're just moving those dots up by 3 inches. And you start to see a few more dots above that line. And you do it a little bit more, and you get a few more dots above that line. What's happening is, because high tides are not evenly distributed in space, they're clustered. Big high tides are rare, little high tides are common. As you get further and further up this distribution, you pick up more and more tides per inch of tide that you go up. So we're now, if we go out to about 12 inches above the historical level, then we're looking at about 45 floods a year. What we're getting now is about 8 to 10. If we go to what's more like the mid-century forecasts for our area of about 15 inches above that 1980s era, we're looking at something on the order of 60 floods per year, 60 to 65 floods per year. So 1 foot of sea level rise, maybe a foot and a couple of inches, and we're looking at going from 8 or 10 floods per year to having 60 floods a year. That's a huge change. These are not big floods. They're not necessarily damaging floods, but every road's going underwater. Every coastal road is going underwater a couple of times a month. And that's a big change. And that's the kind of subtlety that we need to deal with when we're thinking about the future of the coast and the future of our communities. And I'll just keep going. It gets really depressing when you get up to 2 feet of sea level rise. So flood frequency is likely to increase with 1 more foot of sea level to something on the order of 60 floods a year. And these are minor floods, but they're floods. I want to go back to one of those photos I showed earlier, which is the Sawyer Road crossing between Cape Elizabeth and Scarborough, because this is an example of the way I think we're beginning to think about climate change and how it affects our work. The towns of Scarborough and Cape Elizabeth are going to remove Sawyer Road. And one of the reasons is because it's flood vulnerable. The other reason is because it has acted as a serious barrier to tidal flow into the salt marsh, and has therefore been reducing the ability of the salt marsh itself to respond to sea level rise. I just want to point out, in case you don't spot it, there's a car that got washed off the road in the middle of that picture. So this is an example of how we need to be thinking about the relationship between community resilience and our infrastructure and ecosystem resilience. We want to find opportunities where there are roads and other kinds of infrastructure that as we fix the road, we fix the environment as well. And that's sort of where we're headed, is trying to find those opportunities. This is an unusual one since the road is being removed, but there it is. Okay, another opportunity for people to ask me about any of the technical stuff.
There are two questions in the Q&A. One is, do you have any data on high wind events? It seems like there's not only more rainy days, but there seems to be wind a lot of the time.
It's a really, really, really good question, and we have looked at it. It turns out that there's some pretty good evidence. I haven't done it for the Portland Jetport. I've looked at it briefly on some of the offshore buoys. There's some evidence that wind velocities are going up. It's a little hard. The statistics get very messy. The other challenge, of course, is that it's not just the wind strength, but it's also the direction. And that is very hard to even figure out what question you're asking in a technical sense. But there's some evidence for that as well. So there is data available, both from the Portland Jetport has some data around wind direction and wind speed, and which goes back most of that period. And for the last 25 years or so, we've got data from buoys offshore. They can do it as well. I haven't been satisfied with my data analysis on that yet, which is why I don't share it. But yeah, I've been poking around at it.
Great, thank you. The next question is, can you touch on how the sewage project in Portland, underground storage at Back Cove, will help protect Casco Bay?
Yeah, and that's something that was one of the things I couldn't decide what to include and what not to include today. So that's a great sort of reminder. We will get into talking a little bit more about some of the things we're working on, but the City of Portland has been working on reducing combined sewer overflows for several decades. And the cumulative effect of that work has been really quite dramatic. And I pulled the slides, so I can't show them to you. But the total discharges of combined sewer flows, what a combined sewer is it's a pipe that was laid down before we had wastewater treatment plants. So it took runoff from our houses and from our roads and also sewage and dumped it into the bay. When we built wastewater treatment plants, we had to intercept those pipes and take them to the wastewater treatment plant. But the pipes get overwhelmed when there's too much rainfall. You can't get it all to the wastewater treatment plant fast enough because there's just too much water coming down all those pipes because you're also getting all the rainfall. So a combined sewer washes raw sewage, diluted by rainfall and other urban runoff, but still raw sewage, into the bay. And the city's been working on this for about 30 years, and the cumulative effect has already been to reduce discharges significantly, both in total amounts and also per inch of rainfall. Our rainfall is going up, so the discharges without city work would be going up too. They're not going up, they're going down. Per inch of rainfall, we're looking at a significant decline in the amount of rainfall, amount of discharge that happens per storm. But now we're getting these more intense storms and fewer small storms. So the cumulative effect varies from year to year tremendously. And that's one of the things where we keep tabs on that. The City of Portland tracks all of their discharges. Portland Water District has got every one of the combined sewer overflow places with a gauge in it that can measure discharge. So they know exactly how much is coming up into the bay every day now. I think that hits most of it, but and thank God they're building that big. I mean, they've been spending an awful lot of time with a big hole there next to Route 295, but they're getting close to being done.
Great.
So I want to focus a bit on how I'm thinking about climate change, sort of in the way it complicates many of the things we've been worrying about in other parts of our work. So how climate change influences what else we think about. I want to highlight land use change because this is going on the same time that climate change is going on. Changes in land use are going on throughout the region. And so between 2000 and 2020, the total population of Casco Bay rose on the order of 13% or so. And that's pretty close to 0.5% a year. And I will say I work with other people with other national estuary programs around the country where population growth is 4% a year, 5% a year in parts of Florida and things like that. So this is a low relative growth rate, but it is a growth rate. And as that population grows, we need to house people somewhere. We may not be building enough housing, but we are building housing. And that has an impact on the landscape. And what's growing fastest are our ex-urban communities, not the big cities, not Portland and South Portland, but the areas sort of in a ring around those areas. And that means much of the development that's going on is affecting agricultural land and forests. And over that, this data set goes from 2001 to 2016. And I want you to focus just on the largest orange bars really here. And what you can see is we're losing a significant amount of forested landscape, about 16 square miles lost over that 15-year period of forest in the Casco Bay watershed, and we've lost agricultural land. We've lost about 2 square miles of agricultural land over that 15-year period. And most of that is coming back either as developed landscape or as a grassland. So we're seeing significant changes in land use. And I will say this data, since it ended in 2016, is before any of the construction boom that kicked in as we recovered from the economic downturn and as COVID caused everybody to want to move to Maine. So, this data is less severe than what we might see if we were moving forward. But as we develop the landscape, it has a huge effect on stream conditions. And I want to, this graphic, the map on the right-hand side here, is based on some work that Maine's Department of Environmental Protection does, where they go out and they sample the insects in a stream using a standardized sampling procedure. And then they feed it into a giant statistical model that tells them how good the water quality is. This is actually leave a rock basket in the stream for a month. And then they come back and collect it, scrape all the bugs, all the insects, all the invertebrates off those rocks, and put it into and identify everything and do this giant model. And the darker the dots are over here, the lower the water quality is revealed by insects. So the dots tell you what came up as water quality. The background gray is telling you how much asphalt is in that watershed. And it doesn't take any statistics at all to see our darkest areas of gray background have got our darker colors of the dots. There's a direct connection between urbanization of our watersheds and water quality conditions. So the lightest reds up in the upper watershed are in areas with very little in the way of asphalt in the watersheds, and our areas with the worst water quality tend to be our urbanized areas. So there's a direct connection between land use and water quality. As we develop our ex-urban communities, we're putting more and more areas into this danger zone with higher levels of impervious cover. So I want to look specifically at one stream that we've worked a lot on, which is Long Creek. Long Creek is the stream that drains the area around the main mall. The Portland Airport is over here on one side of the watershed. The main mall is in the lower middle section of the watershed. And up here is the Colonel Westbrook Plaza on the edge of Westbrook. The area has been studied extensively and has been monitored for a number of years because there is a cooperative mechanism in there for addressing water quality challenges of this stream. We probably have more data on water quality in Long Creek than anywhere in Maine in terms of freshwater streams. And what I'm showing here is just one of the things we measure, which is dissolved oxygen. And these lines here are the standards for Class B waters, and which are sort of intermediate quality waters in the state of Maine, and slightly less demanding standards for Class C waters for other waters in the state. In this area, most of the waters are Class C waters. Anytime we have a measurement below that value, technically that stream is violating water quality criteria. But these little flunny blobby things, the wider the blob, the more observations we have. So the wide spots are where we have a lot of data. And you can see most of the time in March and April, most of our measurements have pretty good dissolved oxygen levels, well above these criteria levels for water quality. The little rectangles in the middle show you where the middle 50% of the observations occur. And what you can see is by June, something like more than a quarter of our observations are falling below the Class B thresholds. By August, more than almost 3/4 of the observations are falling below that threshold, and a fair number are falling below Class C. So what we're looking at is an expected pattern. Dissolved oxygen is always worse in the summer under warmer conditions, and then it climbs back up. But what we're seeing is any one of these observations would mean the stream fails to meet water quality criteria. These streams are failing to meet water quality criteria day after day after day after day in these summer months. This is over a multi-year period, so it's not every year, every day, but it's happening a lot in those summer months. And a lot of those are serious problems in the upper watershed. So this is something I want to sort of highlight how this relates to urbanization and water quality and climate change and how these are tied together. Climate change affects the hydrology because it affects rainfall. We have less rain for periods of drought, then we have a big storm and we have a gully washer. The result is we have more periods of low flow in that stream, and that makes the stream more dependent on, more likely to warm up when it's a hot day, and especially a hot day in the sun. So you then end up with high temperatures. Well, guess what? Climate change also means we have warmer temperatures. So this stream gets more and more susceptible to those high temperatures and more likely to have those dissolved oxygen problems. Simultaneously, the development of the watershed means we've altered the hydrology because we put all that asphalt down. And that means the water is not draining into the groundwater. It's going directly into the stream and flooding out right after the rain event. It's not staying in the watershed and leaking out slowly over time to feed the stream cold water that's coming out of the ground. That means we're looking again between storm events at lower flows and during storm events at higher flows. And because of it's running off of more of the water is running off the surface and running off of asphalt, which is heated in the sun, temperatures are going up. So urbanization and climate change are both having similar effects, making water quality conditions harder in this stream. So if we can address one of them, if we can address some of the urbanization impacts on the stream, we can lessen some of the impacts of climate change and vice versa. So these are related problems. They're not really separable. And what we've seen out there is we've had a couple of drought years. 2016 was a pretty significant drought, and it had a huge impact on the insect community, which DEP uses to look at water quality. We have, as a result, very few bugs in that stream. It takes several years for the insects to recover. Well, now we need several years without a drought for them to recover. And climate change means those droughts are becoming more common and longer. So we're getting shorter and shorter periods of recovery between events that wipe out the insects. Similar problem to what we had with the green crab. We don't have any cold winters for a few years. The green crabs get worse and they eat the eelgrass. If we have a couple of cold winters, they're knocked back. So it's a similar story of sort of extremes matter a lot. Okay. Another area where similar issues connect some of our other work and land use change is when we think about fish passage and the movement of fish around the watershed. And there's two different stories here, and the two pictures symbolize that. On the left is a brook trout, and brook trout are what's called a cold water species. They really don't do well with water temperatures that get too warm. And on the right are alewives, and alewives are migratory herring that swim upstream and breed in lakes. That photo on the right is actually in Mill Brook up in going up towards Highland Lake. That's a fabulous hike starting right about, give it another couple of weeks, and you'll start to see these fish beginning to swim up into the stream. And you'll see these in the pools all the way up the stream. These fish need to move around, but for different reasons. The trout, during the summer, if they're in a big river or a pond, their water's too warm. And they need to find cold water, and they can do that by swimming up into shaded streams or finding places where there's springs that have colder water. But they have to be able to move to do that. Otherwise, they get trapped in the big lake and the summer's too warm and they die. The migratory fish coming from the ocean have to get their way to the lake, and they have to get all the way there without getting stopped by a road or a dam or something like that. And for both of these groups of species, Maine is a really important northern refuge for these species and other fish that are actually struggling pretty badly in the mid-Atlantic now. So let's take a look at what this looks like on a watershed scale. This is a map where we're showing red dots for dams. We don't show the culverts and road crossings because there's about 16 or 1,800 of them, and the whole thing is covered with dots if you show them. But every place a road crosses a stream, you have a place that could block fish from moving. So what we've got here is showing the areas of accessible streams in green and accessible ponds in green, and all the areas that were historical habitat but are not accessible in orange. And what you can see is we have a very small fraction of the original accessible habitat that was accessible by these species that live offshore and breed in freshwater. They used to have access to a lot more territory than they do now. And for alewives, these migratory herring that breed in lakes, we've got access to about 2% of their historical area in the Casco Bay watershed. For shad and blueback herring, we've got about 15%. They tend to like to breed in the rivers themselves. And smelt, that like to breed in these small coastal streams. They're the blue dots down around the edge. We've got about 56 or 60% of the original habitat accessible. So we've seen a significant change, and we're doing a lot of work going in and replacing culverts. And putting in culverts that allow fish to go through them. And the ideal these days is this kind of an open bottom structure where you've got a natural stream under the road, so that you've got some natural roughness that the fish can hide out in. These kinds of projects are typically not only good for fish, but they also are very good for reducing flooding on those roads. So again, we have this connection between community resilience and habitat resilience. We can do good for the fish, and we can help the road not flood as often. And that's actually how a lot of these projects get done, is towns want to address a flooding road, and we help them do a better job and also address fish issues. So just a little brag, last year was a really good year for doing things on fish passage. We managed to be involved with 5 dam removals last year, and 3 culverts were replaced, and about 5.5 miles of stream were reconnected to the bay or to one of the major lakes and tributaries last year. We don't always do that well, but last year was a pretty great year for reconnecting areas and reconnecting fish and letting them move around the watershed better. And the nice thing about this kind of fish passage work is it really works. I've been involved with a lot of habitat restoration work for many years, and fish passage is about the closest thing to a sure bet you can get. You open up a stream, fish come back. And it's a really remarkable thing to see the numbers of fish that are coming back now to both Cumberland Mills Fishway up on the Presumpscot itself, and the Highland Lake Fishway up at the head of Millbrook Stream there. All right, another moment if anybody's got questions to throw in.
Curtis, I just want to, you asked me to keep track of your time for you. It's 7:50.
Yep, so we got just a little bit.
Yep.
Any questions coming in? I got to pull them up.
I don't see any questions in the Q&A.
Let's keep going.
Yep.
So one of the things that's happened for us as we've thought about climate change is we've changed the way we think about things. We're moving away from this idea of our job is primarily about habitat restoration, which is kind of looking backwards. Restoration, the word is about putting it back the way it used to be. In a climate change world, that's not the goal. We need to be building for the future. And so our goal now is looking forward. And so we're beginning to think much more about how do we encourage resilience of coastal ecosystems. And that means thinking about things like, what's the sediment supply for a salt marsh? How do we increase the sediment supply so as sea level rises, it will accumulate sediments and be able to keep up with sea level rise? And as we think about that, we realize we're almost always working on infrastructure. We're dealing with roads, we're dealing with eroding shorelines. And that means we're beginning to think about what are the ways we build infrastructure that is less negative for the marine environment, and thinking about things like living shorelines demonstration projects and things like that that might help with that. And then we very quickly with that start to think about, well, we're now talking about infrastructure and resilience, and we ought to be talking to communities and thinking about the community. So we've kind of moved over the last decade from thinking our job was habitat restoration in isolation, and now see it as much more in keeping with other things. I'm going to give a couple of examples, and this is where I have to keep an eye on my time. One of the projects we were involved with was a project up on Longreach Lane in Harpswell, where the Department of Transportation removed this 3-foot diameter culvert that's on the left-hand side and put in a 12-foot wide box. So this put a huge amount of salt water into this system that probably that road had been there since the 1870s or 1880s. We're not exactly sure when it was built. It's in the earliest topographic maps of the area. And we went out the next year and mapped the edge of cattails growing in the site. And the purple line was cattails the year before the project was constructed, and the orange line is cattails the year after. So we put all this salt water up there in this marsh, and we killed off the brackish water cattails. That was what we wanted, and I'll talk about that a little bit more in a minute, but that's not the real point of what I want to talk about here. What this is good for is this is opening up the system. As it delivers more salt, it also delivers more sediment, and it produces vegetation, which is more resilient to sea level rise. So a lot of ways that this makes the marsh more resilient to changes. This is what it looks like on the ground. This is one of our vegetation monitoring transects. And before the project, what you're seeing here is on the understory, we're seeing some salt marsh grasses, then a lot of bulrushes, and in the back, some cattails, and all the way in the back, some shrubs, some shrubs and trees. And I want to just point out a shrub that is there in both pictures. So just a year later, we've killed off a lot of the cattails. when we go back in 2018, it's now become a salt marsh. This vegetation in the foreground is almost all salt marsh grasses. And the shrub that was there in those earlier pictures is now completely dead. We've killed off a lot of the trees around the edge here because we put a lot of salt into this system. And this is exactly what we hoped for. We wanted to turn this brackish water system into a salt marsh, which provides better ecosystem services in a lot of ways, but is also more resilient to sea level rise and will continue to be healthier for longer. But we missed something. The picture on the left is Longreach Lane, that road where I showed you that big culvert underneath it. This was in 2019 on one of those spring tides, one of those big high tides I talked about. And you can see we fixed the culvert, or DOT fixed the culvert, but they didn't raise the road. We missed an opportunity here. We should have been dealing not only with the salt marsh, but also dealing with the road and the vulnerability of the road to sea level rise. This is only a 12-year-old project at this point, and we missed this. And I think it's worth pointing out, this is what it means to learn. You make mistakes, you got to learn from your mistakes. Wallace Shore Road is another project we did a year or two later, and you can see the guardrail there. That's on top of a bridge that we put in order to replace another failing culvert in order to help that salt marsh. And again, we missed the need to think about raising that road to address long-term climate change. And this led us to really rethink a lot of what we're doing. And luckily, both of those projects are in Harpswell, and the town of Harpswell's Conservation Commission is fabulous to work with. And they realized that they've got dozens of those low-lying tidal crossings, and most of them are on private roads. And most of those private roads have no road associations. And that means there's nobody in place to raise the money in order to raise those roads to protect long-term access to whatever's on the other side of that crossing. So here we have something that started as a salt marsh restoration world, and now it's all about climate resilience. And what are we going to do to help these communities deal with future flooding that's coming? How do we handle both of those goals at once? So what I want to highlight is the best work, I think, now has to combine these perspectives of thinking about community resilience, community engagement. These are volunteers taking out a dam by hand last year. And then also thinking about community robust infrastructure, habitat resilience, community resilience all at once. And I'm going to skip that one for now. And I want to talk very quickly about something we're working on, which is a regional ocean model that will model water movement in Casco Bay. And the basic idea here started out as something targeting water quality, that we needed to understand water movement in order to figure out how much discharge can come from the wastewater treatment plants. But there are a zillion other potential uses of a good ocean model. We heard from the folks at the Coast Guard that they would love to have a record of water movement for the last couple of days, so when they find an empty kayak, they can figure out where the person might have fallen out of it. We heard from the pilots who wanted to know what the salinity in the upper harbor is, because that determines how deep the boats sink in the water, because it affects water density and buoyancy. There are many, many other users. And so our vision is to go from thinking about ocean models as being something that's developed by scientists for scientists, to bringing in communities and making ocean models that are specifically built with community needs in mind. And thinking about what are the products that we can generate out of an ocean model that address these kinds of community needs. And that means ultimately the community needs to shape the model, not just shape the outputs. And that's where we're headed. And over the next few years, we're trying to develop long-term regional tools that can be updated as needed and extended to address the kinds of needs that the communities have, in addition to doing the water quality things, which is why we originally started the work. And I wanted to end with this, because that's me, the little blonde kid. That's me and my dad. I think I was 6 years old when that picture was taken. And we caught a 64-pound halibut. It was 2 inches longer and 2 pounds heavier than me. And this is a really important family story. And my mom used to tell the story about grabbing the seat of my pants so I didn't get pulled over. And, so this became a really important narrative. And when I think about climate change, I think about the ocean is changing. There haven't been halibut that size off the coast of Maine for people to catch since I was a kid, in any numbers worth speaking of. But this is an important story. And Maine, the coast of Maine is still generating stories and is still generating things that we all ought to care about. And that's what I'm thinking about here. I'm thinking about what are the stories that are going to be generated. Yes, the coast of Maine is changing. Climate change is changing the coast. But what our job is to do is to try to figure out how do we continue to make the communities on the coast of Maine as resilient and as prosperous and as joyful as possible, so that the ocean will continue to make stories and feed us, but also make stories. And that's what I think of when I think about how I want to think about the future of climate change in Casco Bay. I want to make sure the Bay continues to be able to produce really great stories that families will share and will remember for the rest of their lives. And I think we can do it. It takes us away from worrying about whether it's lobsters or blue crab, and instead says, what's great about the ocean and how do we make it as good as it can be? And that's where I think we need to go next. So that's it for me. I think I've got gone longer than I should have, but we didn't get that many questions coming back in.
No,
So
that was wonderful, Curtis. Thank you so much. We do have another question. It says NOAA is allocating a significant amount of funding for fish passage projects in Maine, the Penobscot and the Kennebec. Is any of this funding touching down in the Casco Bay watershed?
yeah, absolutely. I think, let's just say there's a lot of people applying for a lot of effort for that. And I can mention a couple of things that have come up recently. I know there are some projects for a tidal culvert replacement in Brunswick that just got announced. That's actually coming through the coastal program, not through NOAA. Well, coastal program is NOAA, but indirectly, not through the big NOAA grants. We've been applying for NOAA grants for a number of projects. We've got a proposal out now for a half a dozen salt marsh restoration projects around the region. One of the things that's gotten difficult is with all the money coming in the federal funding cycles now, the federal agencies want big proposals. They don't want small proposals. And because of our glaciated landscape, we have a lot of small proposals. And so what we're having to do is work with a lot of partners to put together packages of 8 or 9 projects to apply for money. So it's we're not doing one big Penobscot project. We're doing lots of small things and having to cobble those together into a larger package that we can take to funders to go after. So yes, some of it is landing in Casco Bay. We're still trying to get more. There's a lot of work to be done.
I have a question, actually. You didn't mention lobsters. Could you touch upon what's been happening with the lobster population? You probably did it on purpose.
Yeah, a little bit on purpose. Lobsters are a difficult story because the quality of the science varies tremendously. There are the obvious big global trend is that the southern edge of an economically viable lobster fishery has been moving north for 30 or 40 years. There used to be a viable lobster fishery in Long Island Sound. There used to be one on the south side of Cape Cod. There used to be one in the north side of Cape Cod. Those are all basically gone now. And the underlying science behind that change is not entirely clear to me. I'm sure there are other people who would answer it better, but there's a variety of diseases that seem to be temperature dependent. It looks like the fecundity of female lobsters is temperature dependent. So there's a number of things that affect the ability of lobster populations to stay robust under higher temperatures. So there's, in general, a statewide worry about what the future of the lobster fishery will be. What's interesting is, as of the last time I looked at the data, which is a few years ago now, there was no evidence of a decline in lobster catch and lobster abundance in southern New England, southern Maine, but there was an increase in northern Maine or eastern Maine. So it's not so much the center of gravity is moving, not so much because we're catching fewer lobsters here, but because people are catching a whole lot more in the Bay of Fundy. And that may also relate to water temperature. We are all looking at that and wondering what the future will be. And it's one of the reasons why we're very interested in keeping an eye on development of things like aquaculture, because many of our coastal communities are economically dependent on basically lobster and tourism. And that's a fairly narrow set of economic drivers, and both of them are potentially vulnerable to certain kinds of climate change consequences. So we'd love to see the economies of these coastal communities diversify in ways that continue to support local industries and local communities. We don't want we don't want some sort of large corporate entity to be controlling all of these coastal industries. We want it to stay as much as it can, supporting local community growth. And that's going to be part of the challenge, is how do these change under climate change? What do the new industries look like? Who runs them? Can you still walk out and get a clam license for a couple $100 from your town and make a living? You know, that's a pretty remarkable thing to be able to do. And most of the towns in Casco Bay, licenses are cheap. You need a clam rake and willing to work hard, and then you can work your way up to buying yourself an airboat if you want one.
Thank you. There's one other question. Do you have information about Oars and Bailey's Island and the Cribstone Bridge?
I don't have any specific information on it. It's been one that obviously interesting enough, it's actually in a spot with relatively high current velocities and have had relatively high current velocities forever. So, it's a pretty, last time I heard talking to folks from DOT, it's a pretty stable structure, but I don't know what the status of the road bed itself is. And as you get it's pretty low. So I don't know what its current status is.
Yep.
Mhm.
See, I don't see any other questions popping up. So I just want to say thank you so much to Curtis for coming tonight and giving such a wonderful presentation. It's really helpful to know what's happening in our local area and our local bay. So I hope you're all feeling more informed tonight. And I want to thank Prince Memorial Library for hosting the webinar, and leave you with a call to action to come to some of our other climate series events. We think that knowledge is power, and collectively we can make a difference. And so the more we know and understand about what's happening in our local communities, the more we can do. So thank you so much, everyone.
Thank you, everyone. Thank you, Curtis. Thank you, Penny. And I will say good night.
All right.
Good night.